Hi, I'm Fred.
I'm Derek, and
This is Joe.
This is Joe. We are Team Frittata.
And we are here to explain our engineering project.
Hi, I'm Joe. I did the part of the code where we allowed the user to pick a solar or wind turbine and click anywhere on the grid on top of the picture, and the code fills in a colored square where they click. So we used a switch case statement, a series of switch case statements to differentiate between the different items in the drop-down menus. And then when they click on a specific solar or wind panel, we use G input to take back the X and Y data points for where they click, and we use the rectangle function to plot a filled in square with a different color for each solar or wind panel. We also use the handles.numclicks in order to keep track of how many times they have clicked on a square, and once they reach 10 clicks, then a message box comes up saying that they've reached the limit. So let's go ahead and run that and see if that works.
Okay, so here you can see that we've got two drop-down menus, one for solar panels and one for wind turbines. You can click on either of them and a list will show up of all the solar panels or wind turbines. And if you click on one, you get this big cursor that allows you to plot a square anywhere on the grid. And for each separate solar panel or wind turbine, a different color is going to show up. And then once you plot 10 solar panels or wind turbines, a message dialog box will pop up saying that you've reached the limit.
I'm Fred, and I'll be explaining the load, save, and the grid features. So for the layout, I had color-coded grids for the buttons, red for Boston, orange for San Fran, and blue for LA. So there's a save as image feature. So whatever you type into here, it'll save as that name.png. So eng video test, save as image. And now engvideotest.png is in our working folder, and we can open that outside of MATLAB. And so now we have an image of the blank grid. Another feature we have is save as text. So whatever we type into here, it'll save as that .txt as a txt file. 6 text test saves text, and a message box prompts us, letting us know it has been saved. Now our load feature, we can load only text files. So let's try and load something from earlier, test, and yeah, it has been loaded. And this picture has also been loaded of the previous thing. Okay, and lastly, we have the load button script. And this starts off with the UI get file.txt, so you can only select text files. And and then it sets bounds for y and x based off the w and l that we set earlier, which was our length and width of our array. And basically this part of the script, this plugs it into our plotting script. So curvature 0 would mean that there's no curve. Curvature 1 would mean that there is a curve, so it would plot as a circle. So for case 10 through 18, the curvature is 1 because our wind turbines are circles, whereas our solar panels are squares. And the colors differ for each one. And the load feature reads a text file. So a text file like this, for example, and it'll scroll through, and once it finds a 6, it'll match case 6, and it'll plot at that point there. So with this color 110 and no curve.
This is Derek. For my part of the project, I did the bill of materials, the wind estimate, and the solar estimate. As you see, I've loaded up Boston, selected some solar panels and some wind turbines, and placed them on. So first we'll do bill of materials. All you do is click on the button, and it'll pop up saying your bill of materials has been saved as a text file in the working folder. Go over to your working folder and open up the bill of materials.txt. And as you can see, the quantity of each of the solar panels and wind turbines I have chosen, along with the cost, is up there. And at the bottom, you can see your total cost is printed. How this is done mainly involves accessing the array that is created when the image is brought up, and then edited when solar panels and wind turbines are placed. So as you can see, the number of turbines is the length of where the handles array of the handles array is equal to 1, for example, for this one. So what this does, this is finds where it all equals to 1, puts them in an array, and finds the length of that array. So if there were 2 placed down, then the length would equal 2, or 2 solar panels placed. And it does that for each solar panel and wind turbine. And then the cost is calculated by multiplying by the cost times the number of solar panels. Once all those variables are found, the total cost is found by summing all of them. And then a file ID is used to open up bill of materials.txt, and W for writing into it, and then just using fprintf, each line, and printing out which ones you've entered in. The next thing I did was the solar estimate and the wind estimate. To find the solar estimate and wind estimate, you just click the button, and a pop-up will come up telling you your wind estimate in kilowatts and your solar estimate in kilowatts. And how that is done is using the exact same way to find the number of solar panels placed. Use the exact same accessing of the array, finding the length of handles array. But first, weather.mat is loaded, which is the file from the first project, which tells us the solar energies. Solar for LA is the sum of the row that is LA divided by 12 for 12 months, divided by 10.8 because we want to convert it from kilowatts per meter squared to kilowatts per feet squared. And then you multiply the number of solar panels times however many solar panels you can fit. For our project, we deemed each grid to be 20 feet by 20 feet. Once all those are found, you total using the same sum thing. And then this if statement here, the handle selection is created when a city is chosen. So if you choose SF, the handles.selection is equal to 1, and then Boston 2, LA 3. And what that does is for this part, it's saying, if its selection is 1, it's SF, so that way we can figure out and multiply by the solar of SF. And then times 400 because that is the feet squared. And it's pretty much the same for the wind. Use the exact same accessing, the exact same way to find the wind, and then the exact same if statements and else if in order to figure out the wind estimate.